Welcome back. It's been a little bit since we had a video. Hopefully you have all of your notes so far this unit. We've talked about a lot. We've done translations and reflections and rotations, and we've even done congruent figures. Today we are doing lesson 5 on similar figures. And you actually were given a handout at the end of class that looks about like this to follow along in your notes today. So you're going to glue this into your notebook at the very end. So on your paper, hopefully you've already filled out your name, the date. You're taking these notes on the 30th of September. It's already almost October. So let's jump into it. Two figures are similar when they have side lengths that are proportional, which you spent a lot of time working with in 7th grade. Sorry, that was really crooked. When you have side lengths that are proportional, and then you also have, or the two shapes they have congruent angle measures. So you are looking for two things when you have similar figures. The first being that the two side lengths are proportional, and the second being that the angle measures are congruent. One little warning that we need to always be careful about: when writing similarity statements, make sure the vertices are in the correct order. Order really matters. It's super important that we're paying attention to our precision and that we're being very precise. The symbol for similar is this little guy. Okay? He has a formal name, and I can't think of it right this minute. But that's our symbol for similar. So we're going to jump right into it with question number 1. It's asking us to determine if the two figures are similar. So we need to figure out two things. 1, are their side lengths proportional? And 2, are their angles congruent? First thing I'm going to do is check the angles because they're marked. Angle with angle, 2 with 2, 3 with 3. The angles are perfect, they are congruent. So now I need to check to see if my side lengths are proportional. There are two ways I can do this. The first is to write a proportion. So I'm going to take this bottom side down here, 4, put that over our longer side of this triangle, over 8, and I want to know, is that congruent looking at the same two sides in the other triangle, to 6 over 12. Now, if we remember from last year, to figure out if this is a proportion, there's two things we could do. 1, you could simplify the fractions and see if you get the same thing, or you can cross multiply and see if you get the same number. That's the one I think is easier, so that's what I'm going to start with in this video. I'm going to cross multiply 6 times 8, which is 48. I'm going to cross multiply the other way, 4 times 12, which is also 48. That shows me that that does form a proportion. So the side lengths are proportional, the angles are congruent, so the two triangles are similar. So I'm now going to write a sentence about that. I'm going to write that right here. Both triangles, oops, ran out of space. Both triangles have congruent angles and proportional side lengths, sides, so they are similar. And that's what we were trying to prove. Are the two triangles similar? Yes, they are similar because they have congruent angles and proportional side lengths. So therefore I know that they are similar. Perfect. On to question 2. Are these two rectangles similar? First thing I'm going to do, look at my angles. 90 degrees, 90 degrees. My angles are good. So now I got to write a proportion. I'm going to do short side over long side. So 9 over 15. Does that work with, again, short side over long side? 6 over 9. Whoops. Not an equal sign right there. To tell if they are proportional, I'm going to cross multiply. 9 times 9 is equal to 81. 15 times 6 is 90. 81 is not equal to 90. So because of that, I know that my two side lengths are not proportional. So therefore, the two rectangles are not similar. And because I'm an excellent student, I'm going to go more into detail. Are not similar because the side lengths are not proportional. So if I cross multiply and I do not get a true statement, in this case 81 is not equal to 90, I know that my two side lengths are not proportional to one another, and therefore they are not similar. They do not have a relationship. Alright, we're going to continue on and use these similar figures a little bit more. So it's telling us in the directions that the two figures below are similar, and it wants us to solve for x. So if we already know that they're similar, we know that we could write a proportion and solve the proportion like we did a lot in 7th grade to solve for our x. So again, I'm just going to start by writing that proportion. I'm going to do my short side over my long side, and then keep it equal over here. My short side over my long side. I want to make sure that I'm being consistent. If I have my long side as my 8, that's got to be in the same spot as my x. My short side needs to be with my short side. I'm going to continue. If I cross multiply, I know that those two will be equal. 5 times x is equal to 8 times 9. 5 times x is 5x. 8 times 9 is 72. I'm going to divide both sides by 5, and it will be a decimal. 72 divided by 5 is 14 and 4/10. 14 and 4/10 would be my answer for x. Because once I have my proportion, I can cross multiply and write an equation just like we did in that whole last unit and solve for x. Very similarly, I can do the same thing in the next one. Got to figure out how to write my proportion first. I'm going to do my long side, my 9 over 6 is equal to 21 over x. I encourage you to pause the video at this point to solve the equation. If anybody has the electric free, I had to pause it. I encourage you to pause it to solve for x on your own. Alright, hopefully you're coming back after pausing it, and you're cross multiplying. 9 times x is equal to 21 times 6. 9 times x is 9x. 21 times 6 is 126. And then to get x completely by itself, we're going to divide both sides of my equation by 9, and x is equal to 14. All right. Make sure if you have any questions that you're writing those down in the Google form at the end of this. This is our last one that we're going to do. A student's rectangular desk is 30 inches long and 18 inches wide. The teacher's desk is similar to the student's desk and has a length of 50 inches. What is the width of the teacher's desk? So I know that I'm comparing length and I'm comparing width. So the first thing I'm going to look at is, well, what are the dimensions of my student desk? 30 inches long by 18 inches wide. And I know about my teacher desk is that its length is 50 inches long. And I don't know how wide it is, so I'm going to substitute that out for an x. Just like I did in all my other practice problems, I'm now going to cross multiply. 30 times x is equal to 50 times 18. 30 times x is 30x. 50 times 18 is 900. To get x completely alone, I have to divide by 30, and x is equal to 30. And I'm a great student, so I want to add a unit to it, 30 inches. So my teacher desk is 50 inches by 30 inches. All right, those are all of our notes for today. Hopefully you wrote all those down. And if you have any questions, be sure to write those down in the Google form. There's 2 questions for you to answer.